and welcome to What the Code. Imagine a hacker breaking into your database without touching your servers, stealing your data using just a browser or a simple script. This simple yet devastating attack that can compromise sensitive information is known as SQL injection. In this video, we'll dive deep into SQL injection, explore its types, see the demonstration of the attack, and most importantly, learn how to prevent it. So let's get started. SQL injection is a web security vulnerability that allows attackers to interfere with database queries, potentially leading to unauthorized data access, data manipulation, data deletion, authentication, bypass, command execution. We'll be seeing how this happens going forward in the video. It has been ranked as the number one risk in the OWASP top 10 list since 2010, and it just moved to third position in 2021, which is the last OWASP top 10 list. OWASP Top 10 is a list of top 10 most critical security risks to web applications. It is updated every 3 to 4 years by a team of security experts from around the world. The next list will be coming mid 2025, and I'll most probably be making an entire video on that list, so stay tuned. Let's understand the types of SQL injection. The first one is in-band SQL injection, also known as classic SQL injection. It is the direct retrieval of data through the same channel used to inject the SQL code, meaning the attack and the data extraction happens to the same endpoint. Let's understand with example the first subtype, which is the error-based attack. Here we have a query which is selecting the title and content from an articles table where they are accepting the article ID and the user ID from the user. The user, who is an attacker, sends this payload instead of the article ID. So the final query will become something like this. If you notice, in the attack payload, the attacker has added a double dash at the end. A double dash in SQL means comment. So anything that comes after this will become a comment and will be neglected. And hence, this additional erroneous query that the attacker has passed will result into an error. And that is how he will get the sensitive information like username and password from the database. So that is an example of error-based attack. Now let's understand the union-based attack with an example. Same query, he will be passing another payload where he is using the union and selecting the username and password from users. That means the user table. Now what will happen? Like, it will return the title and content, but it will also additionally return the user ID and passwords from the users table. So this is your union-based attack. The second type of attack is the blind SQL injection attack, where the results are not directly visible to the attacker. Again, there we are taking two examples. So first one is Boolean based. Here the attacker is trying to guess the ASCII character of the passwords. So let's understand what it is doing. It is doing select ASCII substring password 1,1 from users where username is admin. So he's trying to take the password of the admin and taking the substring of the first letter and then converting into ASCII and then checking whether it's greater than 50 or not. So like this, the attacker will send multiple queries, and based on the output, the result will either giving him the actual result or it will give him some error. So based on if the result is actually there, he will understand, okay, it's greater than 50. Then he can try for greater than 60. And then if it returns error, then he understood it's between 50 to 60. Like that, they can try to guess the password of the admin. So that is the Boolean based one. The second one is time based. Here, the attacker is doing the similar thing, but here he has put an if-else sort of a condition. Basically, if you see here, he has put an if ASCII substring password 1,1. Again, he is trying to get the first letter of the password and checking if the ASCII of it is greater than 50. Then if that, then it will sleep for 5 seconds. In the else condition, he has put another condition checking if it is greater than 60. If it will be true, it will be sleep for 3 seconds. Otherwise, it will sleep for 1 second. Right? Like this, the attacker can put multiple if-else statement and different values of sleep. And sleep will actually pause the execution for the amount of seconds that you have passed into it. So according to the response, that the attacker receives, whether he receives the response in 5 seconds or 3 seconds or 1 seconds or however many seconds that he has configured, he will understand that what is the range of the ASCII value of your first letter of the password, and accordingly he will guess the password. The third type of attack is out of band SQL injection. Here the attacker is unable to see the results of SQL query in the application's response. The attacker uses an out of band channel to retrieve data. Let's understand this better by taking an example of DNS based SQL attack. The query is a simple query which is selecting a product from a products where it matches a certain ID. The attacker sends a payload which is this. What this is doing is that it is selecting the password from the users table where the username is admin, and then it is concatenating 3 strings. One is this, the second is the password itself, and then the attacker.com. The attacker.com is a domain of the attacker. Here for the example we have kept it as attacker, it can be anything. So what happens is that it will execute this load file function which will have this file name, which will in turn hit a request to the attacker.com, and the attacker will be monitoring the request, the DNS request reaching to him, and he will see that something like secret 123 has been queried. That means that is the password of the admin. So those were the 3 different types of attack, and now let's see some of the SQL injections practically. For the demonstration, we have 2 files, index.html and server.js. FYI, the link to this code will be available in the description as a GitHub repo. Now you will see that in our UI, it is a very pretty simple UI. We have 3 sections. One is login form, one is the search form, and another is a profile view. And the main part is the login function, search posts, and profile view function. We'll come to these functions when we demonstrate the individual parts. Let's take a look at the server.js, where we are using Express and SQLite as our database, initializing an in-memory database. We have creating 2 tables. One is user tables, one is blog post tables, and we are inserting some entries into both of these tables. FYI, I'm not running my front end on a different server and the server on a different server. I'll be serving my static file, which is index.html, via the server itself using this. So let me just show you that. I will just run the server. Now my server is running. Let me go to the UI, and my UI is running on port 3000. This is the UI for our first attack demo, where we have 2 fields, username and password, which we'll be submitting via the login button. Let's take a look at the code. On click of login, we'll be invoking the login function, which takes the username and password and calls the API at the endpoint of /API/login. So let's go to the server code. Here we are extracting the username and password and passing it to this query, which is going to select the ID, username is admin, and email from the users table where the username and password matches. So to demonstrate this, let's take a look at the users table. Okay, we have a user with the ID Tony and the password Tony123. Let's check in the UI. So I'm going to enter the username and the password, which is Tony123. Login. Yes, I'm able to see it. Now also let's test for a wrong password. Yes, it works. Now let's see the attack. So let me just copy it from here and paste it here. Here we are able to see the details of the admin, which is the first entry in the user table. How this attack worked, let's see that. So this query became like this. It ran till here where username is admin or 1 equals 1, which is always going to be true because 1 equals 1. And hence it returned the first user's detail from our users table, which is the admin. So that was the demo of an in-band SQL injection attack where we could see the results in the same band and immediately. Here now we are going to see the demo of a blind SQL injection attack where we won't be able to see the results. We have a input which takes a search keyword, which will search on our content of blog post and return us the matching content. And the action will happen on the click of search. Let's see the code. The search post function will be called when we click on search. It will take the value of our search and it will call the API/API post search with our keyword. FYI, if you are wondering what encode URI component is, then you can take a look at my encoding, encryption and hashing video. Now let's go to the server code. In the server code, we have this endpoint/API/post/search. We take the keyword and we call this query where it is showing us the ID, title and content from the blog post table. Now let's see the demo in the UI. I'm going to write one of the content which is welcome. Let me search for that. Okay, it exists and it will show us the details. Let me tie something which is not existing. It will give us an empty array. Now let me try this attack. And search. Okay. Now again, let me try a valid string. Okay, it says no such table blog post. Why? Because during our attack, we had added an additional query which dropped the table completely. Okay, so let's see how this actually will look like in our query. So it will become like this. So what happened is, instead of executing just one query, we passed one more query which instructed it to drop the complete blog post table. So that was the attack. Before we move on to the next demo, make sure our server is up and running because it would have crashed demoing the previous attack. In this next demo, I am going to demonstrate the union-based in-band SQL injection attack, which is also known as data exfiltration. In our UI, we are asking for a username and we are going to click on view profile to see his profile. Let's take a look at the code. The view profile functions will be called when we click on the view profile button, and it will take the username and it will call the /API/users profile endpoint. Let's see what this endpoint does. Okay. In this, we are going to take the username and we are going to show the username and email from the users table where the username matches. Okay, pretty simple code. Let's go to the UI. Let's enter Tony. And we are able to see the details of Tony. Now let's try this attack. Now instead of username and email, you are able to see the credit card details and some secret information of the user. Now how did this happen? Let's take a look at the server code. The username was replaced by this attack string. For what we did a union based attack where we did the selection of credit card and the API key from user table where 1 = 1, which is always true, and hence these results were shown as the username and email. So that was the demo for different SQL injections. Now let's take a look at the prevention techniques. The first one is prepared statements. Instead of using our usual query, we can use prepared statements where we have a placeholder for the dynamic input and we pass that as a variable to the db.query. Here, the query structure becomes now fixed, so you cannot add any other query in that. And the parameters are treated as literals, that means it is treated as a single string, and the special characters within are escaped automatically. Let's take an example of one of the attack payload that we had in the demo. If this is the input, it gets converted into a single string and the single quotes are escaped. So what the DB does, it tries to search a user with the username of this entire thing. It will not find it. It will return into an error. That's all. The second prevention technique is input validation. We restrict the user to enter certain kind of characters, like it should not be too short or too long, and it should not have any invalid characters or special characters or any characters that can cause an SQL injection. And in case you can't restrict the user from adding certain kind of characters, you can escape them. So you can make a code such a way that the and dash dash becomes and slash dash slash dash, so that it prevents a comment injection. Now let's see the demo of prevention of one of the SQL attacks that we saw earlier. Let's go to the index.html code. Here let's just change the API endpoint to secure login, and let's see how it is handled in the server. So here what we are doing is we are extracting the username and password. The first thing that we are doing is input validation, that whether the username or password exists, it's not an empty string, and if it is passed, then it should be string and not some any other value. If that's the case, we will send a invalid input response. The second and the most important thing that we are doing is that we are making it as a prepared parameterized query, where we are passing it as a placeholder. Then in the db.get, we are passing the list of parameters as an array, and then we get the user details. And here, if you see, we are only taking the username. And then after we get the user details, whether the user exists or not with that user ID, then we check the password that we got from the UI with the user.password. And if that matches, then we send the user data, deleting the user password since we don't want to send any sensitive data. So let's see this in the UI. FYI, don't forget to restart your server before running the UI, since you made a change in the API route in the index.html and it is served from the server. So you will need to restart your server. Now let me give the username as Tony and paste the attack. And it gives us invalid credentials, since it considers this entire thing as a single string and there is no user with a user ID of this string. Now let's understand how we can secure our app against SQL injection attacks with the use of ORM. ORM is a programming technique that lets developers work with database using object-oriented programming concepts instead of writing raw SQL queries. So you work with objects in your programming language. The ORM handles the conversion between your objects and the database tables automatically. Here is an example of a query using Prisma ORM, where the user is trying to find a user with a given username. In case built-in methods of an ORM like find unique do not serve the purpose of your query, then you can write your own queries, but those are also safe. Unless you pass it within a single quote, then they are not safe. Now let's take a look at some best practices. First one, database configuration. Always follow the principle of least privileges. That is, limit the permissions, limit the allowed commands. Second, restrict the database access to certain hosts that are known where your API is hosted, and limit the connections. Second, query construction. As discussed, use parameterized queries. Validate and sanitize all inputs, and use ORMs when possible, as they have built-in security of validation and sanitizing all the inputs. The third one, error handling. Do not expose SQL errors. Give a generic error so that the attacker has the least amount of information about your data and the database. So that was it for the SQL injection attack and its prevention. I hope you guys understood what it is and how to prevent it. I'll see you in the next video.